In this video, we're looking to take the indefinite integral of x times the square root of x minus 1. Now, it turns out we're going to be able to do this with u substitution, although it's not the most straightforward u substitution. So let's take a look. So I'm going to let u equal x minus 1, because I know I can make that one because du then is just dx. If there was a constant multiplied by x, that still wouldn't be a problem. Now when I go to make my substitution, this is going to become a square root of u, and that's going to become a du, but right now we still have an x, and we can't have an x in there. Well, remember, if u equals x minus 1, add 1 to both sides, and you get u plus 1 equals x. Now, that's going to be our other substitution. So we're going to put in u plus 1. Now, it may not look like we've improved anything, but we actually have, because we can distribute this square root. So we get u times the square root of u plus square root of u du. And let's go ahead and write those as power functions. So that's u to the 1 plus, or times u to the 1/2. That's going to be u to the 3/2 plus u to the 1/2 du. And now we can do the antiderivative piece by piece. So reversing the power rule, we're going to increase the power by 1, so u to the 5/2 and divide by the new power, divided by 5/2. Plus u to the 3/2 divided by 3/2 plus c. Now we never want to leave a fraction in a fraction, so the first thing we're going to do is flip and multiply those fractions. So 2 u to the 5/2 over 5 plus 2u to the 3/2 over 3 plus c. The other step we have to make on an indefinite integral with u substitution is to substitute back. Remember, u is x minus 1. So we have 2 times x minus 1 to the 5/2 over 5 plus 2 times x minus 1 to the 3/2 over 3 plus c. And there's our antiderivative.